All right, this is lesson 4 in the powers and exponents unit. We're looking at some applications today, so some word problems in different areas of real life where powers and exponents would be used. The first kind of set of problems here, I've split them into like the different sort of subcategories, different types. The first set of problems is all to do with area and volume, so geometry applications. Let's have a look. So first one, a circle is inscribed in a square. That means like the edges of the circle are just touching the sides of the square. Write an expression with powers to determine the area of the shaded region. Then evaluate and round your answer to the nearest tenth. Okay, so the shaded region would be the area of the square. I'm going to use highlighters here to show. So the area of the square would be all of this, what I'm highlighting in pink. And then we'd want to subtract the circle from that. So let's do the square first. So the area of the square would be 6 meters times 6 meters. So we could write that, it says to write it with powers. So because I'm multiplying 6 twice, I could write it like this, 6 meters squared. And then the area of the circle, so any circle is pi times radius squared. And the radius of the circle, I'm just going to label it here, r is half of 6, would be 3 meters. So the area of the circle would be pi times 3 meters squared. And so we can evaluate the shaded region as 6 meters squared minus pi times 3 meters squared. And you can type that into a calculator and get, it says approximately to the nearest tenth. So it would be about 7.7 meters squared as our final answer. Okay, let's try this one. It says a concrete block is created with a cylindrical hole that has a diameter of 2. Write an expression with powers to determine the total amount of concrete needed to make the block. So we want to do essentially the volume of the prism minus the volume of the cylinder. So the volume needed would be, so the volume of the prism would be 4 meters times 4 meters times 4 meters, length times width times height. So it would be 4 meters cubed. And now we want to subtract the volume of the cylinder. So if you recall, any prism is, the volume is area of base times height. So the volume of this cylinder would be area of base, which is 1 times pi times 1 meter squared, and then times the height of the cylinder, which would be 4 meters. Okay, so there's an expression for the, or I'll call this the block minus the hole. Okay, and so if we type that into a calculator, we get approximately, I'm using a little like squiggly with my equal sign because it's not exact, 51.4 meters cubed this time because it's volume. And I've multiplied 3 different meter lengths together. Okay, write an expression with powers to determine the side length of the hypotenuse. So hopefully you've learned the Pythagorean theorem before. So the Pythagorean theorem says that a squared plus b squared, actually, a squared plus b squared equals c squared. And so if I was going to solve for this missing length, what we would want to do is we would want to find 5 squared plus 12 squared, and that would give us c squared, but we would want to take the square root of that to get just c. And then let's evaluate that. So 5 squared would be 25. 12 squared would be 144. 25 plus 144 is 169. And the square root of 169 is 13. So the missing side length would be 13. But see how we used powers to write that? We had powers of 2 there. Okay, So that's how you'll see powers and exponents in some geometry applications. Let's do population growth now. We did one in the first lesson with bacteria. This time we're going to see a pine beetle question and then another bacteria question. So let's read this one. It says, scientists studying the mountain pine beetle have found that their population can grow with this, can be described by this equation. P is the population and N is how many years have passed. Determine how many pine beetles there will be after 2 years and then after 10 years. So after 2 years, we're going to do 15,000 times 2 to the power of 2. Now remember, we have to use the order of operations here. So I'm going to evaluate the exponent first. Actually, I'm going to go underneath 15,000 times 4, and 15,000 times 4 is 60,000. So there would be 60,000 pine beetles after 2 years. Let's do 10 years. 15,000 times 2 to the 10. Remember, we have to multiply the exponent, do the exponent first. A lot of students make that mistake. They forget about the order of operations. 2 to the power of 10 is 1,024. If you multiply 10 twos together, that's what you get. And that is equal to 15,360,000 pine beetles after 10 years. That's a lot of pine beetles. Okay, next question. A culture of bacteria in a lab contains 100 bacteria and the number of cells doubles every day in an equation that looks like this. What does n equals 0 indicate? So n would be the number of days, so 0 would be the beginning, the initial population, which in this case would be 100. Population, day 0. How many cells are present after 1 week? So 1 week is 7 days. We're working in days in this equation, so we need to use days, not weeks. So I'm going to plug in 7, where the n is. And remember, we have to evaluate the exponent first. We have to use order of operations. So 2 to the power of 7 is 128, and 100 times 128 is 12,800 bacteria. Okay, let's look at a couple of other examples now. A white blood cell is about 0.014 millimeters in diameter. If it were magnified by 10 to the power 4 times, so this is how you'll often see magnification written as a power when you're looking at microscopes. How large will it appear in centimeters? So there's a good connection between this unit and this scale diagrams unit. So let's figure out the length first and then we'll convert it to centimeters. So the length is going to be 0.014 millimeters times, so it's going to look 10 to the 4 times larger, so 10,000 times larger. Remember to do the exponent first. So 10 to the 4 is 10,000. And so that will be 140 millimeters. Okay, change to centimeters now, because that's what the question asks. So again, a good connection to the scale diagram unit. So 140 millimeters, and there's 1 centimeter for every 10 millimeters. So you can divide this by 10 and you get 14 centimeters. So that's really large. So the white blood cell is going to look like it's 14 centimeters in diameter. Okay, and last but not least question. A phone battery loses about 20% of its charge every hour. This is a typical way that batteries work. And this situation could be modeled with this formula, where T is time that has passed. Determine the battery life after 3 hours. So we're going to plug in 3 for T. This time we're dealing with a fraction. Okay, we want to do the exponent first. Order of operations is important. So 4 to the power of 3 is 64. 5 to the power of 3 is 125. And if you change that to a decimal, it's 0.512. And if we multiply that by 100, it is 51.2. So the battery life will be 51.2%. Okay, so those are some ways you might see powers and exponents used in everyday life. And the most important thing in almost every single one of these questions is we had to use the order of operations. So when you're given an equation to work with and it has multiple operations in it, you do need to use BEDMAS and do the exponents in the brackets first. All right, so that's the end of the lesson.